All right, so 7.1 goes over adding and subtracting polynomials. We're first going to be looking at types of polynomials and degrees of monomials and polynomials. So when you look at a degree of a monomial, if it's just one single term that does not have a variable attached to it, the degree is 0. If it has a variable attached to it, you add up those powers. So if it's just something like 3x, the power on it is an invisible 1, so it's the degree of 1. If it's something like 1/2 ab squared, that a has an invisible 1 attached to it, so you would add the 1 and the 2 to get a degree of 3. Anything that does not have a variable attached to it or more than one term with addition or subtraction is not a monomial. So if we look at the first set of examples, we're just finding the degree of each monomial. For a, we're given 5x squared. So automatically, that 2, that's your power, is your degree. For b, we have negative 1/2 xy cubed. Well, the x has an invisible 1 on it, so we would add the 1 and the 3 to get a degree of 4. For c, we have 8x cubed y cubed. So the 3 on the x and the 3 on the y we add to get a degree of 6. For d, we just have negative 3. So think about this as if there was an x attached to the negative 3. In order to get rid of that x, it would have to have a power of 0 to turn it into a 1, which would just be negative 3 times 1, which is negative 3. So with that, it gives us a degree of 0. For e, we have negative 3x to the 4th power. The power there is the 4, so automatically we have a degree of 4. For f, we have 7c cubed d squared. So we add the 3 and the 2, and we get a degree of 5. For example, g, we have 5/3 y. That y does not have a power on it. However, it is an invisible 1, so automatically our degree is 1. And then with h, we have negative 20.5. We do not have a variable attached to this one, so automatically it's a power or a degree of 0. For the next part of your lesson, we are just going to be classifying these polynomials. We're first going to make sure that these polynomials are in standard form. When they're in standard form, the highest degree term comes first, and then it goes down from there, from left to right. With that, you are going to be asked for the degree of the polynomial. Your degree of the polynomial is the highest degree. So the highest power gives you the degree of the entire polynomial. Your leading coefficient, remember a coefficient is the number that's in front of the variable, so the number in front of the letter. That leading coefficient is the number that's in front of the variable that has the highest power when it's in standard form. So if we look at example A, we have 15x minus x cubed plus 3. If we put this in standard form, the term with the highest power comes first. So that would be the negative x cubed. You'll realize the sign that's in front of the term stays with the term. So from there, we would have a 15x, which is positive, so that's plus 15x, and the 3, so that's plus 3. From here, our degree comes from the highest power. Your highest power is 3, and then your leading coefficient comes from the term that comes first in the standard form. Your first term in standard form is that negative x cubed, so its coefficient is a negative 1. From there, you would have that positive 4. So in standard form, you have negative 9z plus 4. Your degree for this one, there isn't a power on either of these terms, so you have an invisible 1 on that z, so your degree is just 1. Your leading coefficient comes from the first term in standard form, which is negative 9. For example C, we have t squared minus t cubed plus 10t. So the highest powered term goes first in standard form. So that's going to give us a negative t cubed. Next we have t squared, so it's a positive t squared. And lastly we have that negative 10t. Your degree for this is the highest power, which is 3. And then your leading coefficient is the coefficient or the number in front of that t cubed, which is negative 1. For D, we have 2.8x plus x cubed. In standard form, this x cubed is going to go first. Then we're going to have that 2.8x that comes next. Your degree of this is the highest power, which is 3. And then your leading coefficient, that x cubed is your first term, so the coefficient or the number that's in front of the x is an invisible 1, so your leading coefficient is 1. The next part of your lesson goes over classifying and telling the type of polynomial that you have with each of these. So with these, if you have one term, it's called a monomial. 2 terms is a binomial. 3 terms is a trinomial. And 4 or more terms is called a polynomial. So when you're asked for the type of polynomial, you're giving me either monomial, binomial, trinomial, or polynomial as your answer. So we're going to be doing the same exact things that we did in the last section, except now we're telling the type of polynomial as well. So in example 3a, we're given negative 3z to the 4th power. This is only one term, so in standard form, it is what it is. It's just that negative 3z to the 4th power. The degree of this polynomial is the 4. Your leading coefficient is the negative 3. And the type of polynomial that you have here, it's one term, so it's a monomial. For example B, we're given 4 plus 5z squared minus x. So in standard form, highest degree first, that's that 5z squared. Then we would have that minus x, and then lastly the 4. The degree of this polynomial is 2, since it's the highest degree. Your leading coefficient is the number in front of the variable that has the power of 2, which is 5. And the type of polynomial you have here is 3 terms, so that's a trinomial. For example C, we are given 8q plus q to the 5th power. So to put this in standard form, this is just going to be q to the 5th power plus 8q. The degree of this polynomial is 5. The leading coefficient is 1. And the type of polynomial, it's 2 terms, so it's a binomial. For example, D, we have 5x to the 4th power minus 6x squared plus 3x to the 5th power minus 7. So in standard form, we're going to have that 3x to the 5th power that comes first. Then we have 5x to the 4th power minus 6x squared minus 7. From here, the degree of this polynomial is the highest degree, so that's 5. Your leading coefficient is the number in front of the variable that has the 5th degree, which is 3. And the type of polynomial that you have here, there's 4 terms, so this is just a polynomial. The next part of your lesson goes over adding and subtracting polynomials. When we're adding and subtracting polynomials, we want to keep in mind our like terms. Like terms have the same variable and same power. So you cannot combine 2 terms unless they are like terms. When you have like terms, again, it's the same letter with the same power. If we look at some adding examples, so adding polynomial examples, for A, we have 2x cubed minus 5x squared plus x plus 2x squared plus x cubed minus 1. For this one, I'm going to get rid of these parentheses to start with. Because it's addition, I can just rewrite it without those parentheses. From there, I'm going to just combine like terms. So starting with my highest degree, I have x cubed. So the 2x cubed and the x cubed, I'm going to combine. 2 plus 1, because there's an invisible 1 in front of that x cubed, is going to give me 3x cubed. Then I have the negative 5x squared and the 2x squared. Negative 5x squared plus 2x squared is negative 3x squared. Next, we have that x. And lastly, we have that y. Or sorry, that negative 1. So we just have 3x cubed minus 3x squared plus x minus 1. For example B, we have 3x squared plus x minus 6 plus x squared plus 4x plus 10. So again, I'm adding these two polynomials. I'm just going to get rid of those parentheses by rewriting it. And then I'm going to combine my like terms. So to start with, we have 3x squared. I have another x squared. That's going to give me 4x squared. Then I have x and 4x. That gives me 5x. Lastly, I have negative 6 and 10, which gives me a positive 4. So that's just 4x squared plus 5x plus 4. For example C, we have b minus 10 plus 4b minus 3. So again, I'm just going to rewrite this without the parentheses and combine like terms. So my like terms here, that b plus 4b is 5b, and that negative 10 minus 3 is negative 13. So we have 5b minus 13. For example D, we have x squared minus x minus 2 plus 7x squared minus x. So again, just going to rewrite this without the parentheses. X squared minus x minus 2 plus 7x squared minus x. Combine my like terms. X plus 7x is 8x squared. X squared plus 7x squared. Then I have my x, my negative x, and my negative x, which is negative 2x. And lastly, that negative 2 drops down. So it's just the 8x squared minus 2x minus 2. For our next set of examples, we are finding the difference of these polynomials, so we're subtracting. When we subtract two or more polynomials from each other, we need to make sure that we distribute that negative into the set of parentheses. So if we look at example A, we have 4n squared plus 5 minus parentheses negative 2n squared plus 2n minus 4, close parentheses. So we're going to start this one by distributing the negative into the second set of parentheses, which is going to change the sign on each of those terms. So if I rewrite this, I have 4n squared plus 5, a negative times a negative 2n squared is a positive 2n squared. A negative times 2n is a negative 2n, and a negative times negative 4 is a positive 4. So now I'm just going to combine like terms. 4n squared plus 2n squared is 6n squared. I then have the negative 2n, which drops down because it doesn't combine with another n. Lastly, we have 5 and 4, which is 9. So this just gives us 6n squared minus 2n plus 9. For example B, we have 4x squared minus 3x plus 5 minus parentheses 3x squared minus x minus 8, close parentheses. We are going to distribute this negative in and change the sign on each of those terms, getting rid of those parentheses. So it's 4x squared minus 3x plus 5 minus 3x squared plus x plus 8. Next, we combine our like terms. So 4x squared minus 3x squared is just x squared. Negative 3x plus x is negative 2x. And 5 plus 8 gives us 13. So it's x squared minus 2x minus 13. Looking at our next example, we have p squared plus p plus 3 minus a negative 4p squared minus p plus 3. So again, we're going to distribute the negative. So it's going to be p squared plus p plus 3 plus 4p squared plus p minus 3. P squared plus 4p squared is 5p squared. P plus p is 2p. And 3 minus 3 cancels out and gives us 0. So it's just 5p squared plus 2p. For example, D, we have negative k plus 5 minus 3k squared minus 6. So again, we're going to distribute the negative. It's going to give us negative k plus 5 minus 3k plus 6. This is a 3k squared and minus 3k squared. There we go. All right, so from here, combine your like terms. We have a negative 3k squared. Then we have a negative k. Then we have 5 plus 6, which is 11. So it's just the negative 3k squared minus k plus 11. Your next example tells us that a penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. It tells us that the polynomials represent the heights in feet of the objects after t seconds. For A, just asks us to write a polynomial that represents the distance between the penny and the paintbrush after t seconds. So we're finding the difference of these. So we're going to be subtracting them. So we're going to have negative 16t squared minus 40t plus 200 minus negative 16t squared plus 100. If we distribute the negative into the second set of parentheses, it's going to give us negative 16t squared minus 40t plus 200 plus 16t squared minus 100. Your t squares are opposites, so they cancel out. We're going to have negative 40t, and then that 200 minus 100 is a positive 100. So negative 40t plus 100 is the distance between that penny and that paintbrush. For our last example, it tells us that the polynomial negative 16t squared minus 25t plus 200 represents the height of the penny. We are going to do the same thing and just write the difference between the penny and the paintbrush after t seconds. So from the question before this, that paintbrush was negative 16 t squared plus 100. So we are going to take the negative 16t squared minus 25t plus 200 and subtract negative 16t squared plus 100 from it. So distribute the negative. We have negative 16t squared minus 25t plus 200 plus 16t squared minus 100. Again, we have opposites when it comes to this t squared, so they cancel out. That negative 25t gets dropped down, and then that 200 minus 100 is a positive 100. So it's just negative 25t plus 100.